Now, in this video, we are going to take up one more problem on projections of lines. How to analyze this problem and solve it manually. A line has its end capital A 10 mm above HP and 15 mm in front of VP. The end capital B is 55 mm above HP and line is inclined at 30 degrees to HP. The distance between the end projectors is 50 mm. Draw the projections of the line. Determine the true length and its inclination with VP. So this is the problem given to you. Now how to analyze this? First we need to plot the data. He says a line capital A is 10 mm above HP. So this is the distance which is 10 mm above HP. When it is in space, if you can see here, the line is 10 mm above HP and 15 mm in front of VP. You can see that in front of VP, and when you look from the top view, you can see the distance in front of VP on HP. So you mark this point as small a, and here it is capital A. When you look from the front view, you can see the distance above HP. The distance is seen in the vertical plane, and you can see the distance, and when it is projected onto the vertical plane, we are going to mark this point as A dash and capital E. And then he says the line, the end point B is 55 mm above HP. So which is the distance? It is 55 mm above HP. You can see that distance above HP in space. So this is the line which is in space now. Now, once you get the distance above HP, when you look from the front view, I can see the distance in the vertical plane, and you can project that point onto the vertical plane. So we got the distance above HP. So now we got the locus of B, and we know the locus of B in the front view. Then he says the line is inclined at 30 degrees to HP. So what does it mean? It is the true length of the line which is inclined at 30 degrees to HP. If you look from the front view, since the inclination is given with respect to VP, where you can see the distance or angle that can be seen in the vertical plane. So we have a line, you draw a line which is inclined at 30 degrees to HP such that it will going to cut the locus of B in the front view. So when you look from the front view, you will be able to get the inclination. So from A dash, you draw a line which is inclined at 30 degrees to HP such that it will going to cut the locus of B in the front view. So you mark this point as B1 dash, and since it is the true length, so you mark this as capital B. And he has also given the distance between the end projectors. So the distance between the end projectors, you have a projector A, which is this point, and this, when it is looking from the front view, that image will going to fall on the vertical plane. So this is the end projector for the projector A in the front view. And you know that the distance between the end projectors is seen in both in the vertical plane and as well as in the horizontal plane. So what you can do is from this point, you measure 50 mm and draw a vertical line which will going to cut the locus of B in the front view. So you mark that point as B dash in the front view and join between A dash and B dash with the dotted line. So and also we know that when you look from the top view, you can see the distance between the end projector in the horizontal plane also. What does it mean? You draw a line from here, you are already having a projector A. From here you measure 50 mm and draw a vertical line in the horizontal plane also, which can be extended till wherever you have the vertical plane, till to such distance you can project this. So this is how, whatever the data which was given, we have taken all the considerations. Here capital AB1 is the line which is in space. And you know that this is the true length of the line. So when you look from the top view, you can see the distance 15 mm in front of VP, the point A, and similarly the B1 is also 15 mm in front of VP. Then only the line is parallel to VP. So where you can see the line parallel to VP, you can see that line parallel to VP in the front. front view, in the top view. And that image will going to be seen in the top view, that is on the horizontal plane. So how to proceed with the drawing the orthographic view? How to do that? So first what we will have to do is, first we are going to draw the XY line and we will going to mark VP and HP. So we know that the distance above HP is seen in the vertical plane. So from XY line we measure the 10 mm distance and draw a horizontal line. And similarly 15 mm in front of VP is seen in the horizontal plane. So from XY line you measure a distance of 15 mm below the XY line and draw a horizontal line. You take any point and draw a vertical line such that it will going to cut these two parallel lines. And you mark this point as A dash, and you mark this point as A, and you mark this as capital A, and you mark this also as capital A. Then you know the distance above HP. The end point of the B is above HP by 55 mm. So where is above HP? Above HP distance I can always see from the front view. That image will going to fall on the vertical plane. So from XY line you measure 55 mm and draw a horizontal dashed line, and that will going to be the locus of B in the front view. So you mark that it as the locus of B in the front view. And then with A dash's center you measure an angle of 30 degrees because the line is inclined at 30 degrees to HP is given. A line is inclined at 30 degrees to HP means it is the true inclination line which is given with respect to HP. As you know, the angle is with respect to HP. That angle can be seen in the vertical plane. So from A dash you measure an angle of 30 degrees and draw an inclined line such that it will going to cut the locus of B in the front view. You mark this point as B1 dash and join between A dash and B1 dash with little bit thicker than the XY line. So you will go to, since this is the true inclination line and the length what you will going to get, it is true length. So you mark this point as capital B, you mark this point as capital A. And also he has given the distance between the end projectors is 50 mm. So from the projector A you measure 50 mm both in the vertical plane and also in the horizontal plane. And then join these two lines and extend it on either side. So that means in the front side, that is in the front view, you have the locus of B in the front view. So obviously it will going to cut the end projector on that to the locus of B. Then you mark this point as B dash, join A dash B dash with a dotted line. And in the top view also you project this end projector to the top view. So this is how you will be able to write the data which was given in the problem. Now the next thing is, I need to find out, see we have the true length, we have the front view true length, but we don't have the top view. So what we can do is, so you know that this is the, we know that this is the true length in the vertical plane. What does it mean? If the true length is in the vertical plane, then that should be parallel to vertical plane. So where you can see the parallel to vertical plane, I can see from the top view. So that means when you look from the top view, you can see the distance in front of VP here, which is 15 mm. Similarly, the B1 should also be in front of VP by 15 mm. Then only the line will going to be parallel. You can see that line is parallel. So where you can see the distance in front of VP, I can see the distance in the top view. As you look from the top view, there I can draw that image will going to be seen in the horizontal plane. How I can do that? With from A you draw a vertical projector to the horizontal plane. Similarly from B1 also you draw a vertical projector to the horizontal plane. Then you have got A and you have got B1. Join A and B1. So once you join between the A and B1, so that will going to be the top view for the front view true length. You have the front view true length is here. So that I want to write the top view. The top view will going to be, what is the front view true length line? A dash B1 dash. You can see here A dash and B1 dash. The top view for A dash B1 dash is AB1. So the AB1 is going to be parallel to XY line in the top view. Since it is parallel to XY line in the top view, obviously you will be able to get the true length in the front view. So this is the concept which has been applied. Now the same thing we can do that here. So from B1 dash you draw a vertical projector to the top view with a vertical projector to the top view till to the locus of A in the top view. That means A is in front of VP by 15 mm and B1 should also be in front of VP by 15 mm. Then only the line will going to be parallel to the XY line in the top view. If the line is parallel to XY line in the top view, then the corresponding front view will going to be in true length. You can see that. So which is the corresponding true length? For A it is A dash, for B1 it is B1 dash. So this will going to be in true length. So apply that concept. So write a top view for this. Once you write the top view for this, we can see AB1. Both AB1 is in front of VP by 15 mm, which is that from this point to capital A and also from this point to capital B1. So both are at equidistance from the vertical plane. So therefore the line is parallel to VP. So where you can see that image is seen on the horizontal plane. Therefore I have written the image of the front view true length in the top view. So you got this line. But actually what happens, this top view point of B1 should come and lie on the locus of B, should come and lies on the distance between the end projectors. Why? Because B dash is the one which is lying on this vertical projector. Both B dash and B should lie on the same line. But B1 is in front of VP by 15. Now what I want the top view point of this should lie on this end projector. Then only you will going to get the top view. But how to get the top view? So with A as center, with this as center, taking the radius of AB1 which is in space, you are rotating this line such that this point will going to lie on the end projector distance. You can see that. So when you are doing it in space, what happens to the corresponding image in the top view? The B1 which is there with A as center, taking the radius of AB1, you are drawing an arc such that it will going to come and touches the distance between the end projectors in the top view. And you mark this point as small b, then join A to B with a dark line. So now we got the locus of B in the top view. So this is how you will be able to get the top view for the front view. Now how to do that in your drawing now. So till we know how we are able to get it. Now I want the top view point. Where should the top view point of B should lie? The top view point of B should lie on this particular end projector line, which is B dash is here. B should also lie on the same line of the point end projector of B dash. So with A as center, taking the radius of AB1, you draw an arc such that it will going to come and cuts the end projector line of the point B. And you mark, since it is B dash here, the top view point of B dash is B. So you got this point B here. Then draw a horizontal dashed dot line in the top view also. Now we got the locus of B in the top view. Join between A and B with a dark line. So this is how you will be able to get the top view for this projector of end projector, that is between B dash and B. Once you get this, now what I want to get the true length in the top view. So to find the true length in the top view, what should I do now? With A as center, taking the radius of this line which is in space, the line which is in space, you start rotating such that A is above HP by 10 mm, that B should also be above HP by 10 mm only. So with A as center, taking the radius of AB, you draw an arc. That means you are rotating such that this B also will be above HP by 10 mm. So while doing so in space, what happens to the image in the vertical plane? With A dash as center, A dash B dash as the radius, we are drawing an arc such that both A dash and B2 dash are above HP by 10 mm. So when it is in space, both capital A and capital B2 are above HP by same distance, which is 15 mm. Now the line is going to become parallel to HP. Since the line has become parallel to HP, obviously that line, when you look from the top view, will going to be able to see the true length of the line. If you look from the front view, A dash B2 dash is the front view line which is parallel to XY in the front view. Obviously the corresponding top view, which is that A B2, will be in true length. So you will be able to get the angle phi. So this is how you will be able to find the true inclination with respect to VP. How to represent that on the drawing now. So what we want to find out the true length in the top view. To find the true length in the top view, I need to take the front view. Which is the front view line? A dash B dash. With A dash as center, taking the radius of A dash B dash, you draw an arc such that both A dash and B2 dash are above HP by 10 mm only. So it means the front view line is parallel to XY. When the front view line becomes parallel to XY, then its corresponding top view. What is the corresponding top view of A dash B2 dash? The corresponding top view of A dash B2 dash is A, but B2 is not there. I need to get that. So from B2 dash, you draw a vertical projector such that it will go to cut the locus of B in the top view. And then to this you are writing the top view. Therefore, just beneath that you will go to get the B2 and you mark that point as B2. And since it is parallel to XY in the front view, obviously in the top view it is in true length. So you mark this point as capital A and you mark this as capital B. And then you identify this angle as phi, join between A and B2 with little bit thicker than the XY line. By using the protractor, you measure an angle of this phi. It will go to be 41.63 on computer, but when you are doing it manual, it will be 42 degrees. And the true length of this line will going to be 90 mm. So how do I know that my problem is right? Both B dash and B will going to lie on the same line. This is the point number one. You know that this is the front view because its corresponding top view AB is inclined. And you know that this is the true length in the front view, that is A dash B1 dash, because its corresponding top view AB1 is parallel to XY. Similarly, you know that this is the true length in the similarly you know that AB2 is the true length in the top view. Therefore, its corresponding front view, that is A dash B2 dash, is parallel to XY in the front view. Therefore, you have got the true length in the top view. So this is how you will be able to analyze the drawing in 3 dimensions, and also you are able to write the orthographic view by using the manual sketch.